In this lecture, we are going to look at the classic row compression. And this is one of the types of row compression available in DB2, and it was first introduced in version 9 and has been carried forward to version 10 and 11 as well. So let's get started. So whether you work with classic or adaptive row compression, you have to have a table level compression dictionary that will be used to compress the table data. Now this dictionary is used to map the repeated byte patterns that are found in data rows to smaller symbols, and these smaller symbols then replace these longer byte patterns on the data page. So in this example, if I were to create a table level dictionary, I would start by identifying the values that are repeating in both these rows. And I can see the value 500, the column values for city, state and zip code that are repeating for Fred and John. Now once you identify that, you create a compression dictionary, or the compression dictionary is automatically created based on the repeating patterns and values, and a symbol is used to represent these longer values in the compression dictionary. Now when you compress your table data, then these symbols replace the actual longer string values into the column. So over here in the department column, since 500 is represented by a shorter symbol 1, so we have 1 over here, and similarly we do it for city, state and zip code. So to store the value 24355, you would need some bytes, and that would be always larger than what would be required to store the number 4 in this example. So this is the simplest form of creating a compression dictionary, and this is how compression basically works. So let's look at another example of a compression dictionary that is more relevant over here. So we have these two rows, Fred 500, 10,000 Plano, Texas and the zip code. Then the other row, John 500, 20,000 Plano, Texas and the zip code. And this is how rows are placed on the data page, one after the other serially. So the length of the column would depend on the individual length of these column values. So here when a data dictionary is created, it is created in such a way that it picks up the value 500 from the department column, assigns that a shorter symbol, and it also sees that in continuation of these three columns, that is Plano, Texas and 24355 are repeating as is. So instead of storing individual column values in the data dictionary and mapping them with shorter symbols, it picks up the entire string in continuation, and because this is repeating as an entire string onto the data page, so it gives us that a shorter symbol as well. Now when you look at the compressed row, so here we have Fred for the first row, 500 is substituted with 01, and then we have 10,000 because 10,000 has not been picked up into the data dictionary because it's not repeating. And then you have to look at this Plano, Texas and 24355, the three column values for city, state and zip code. Now these three are taken into this data dictionary, and we have this 02 as the assigned symbol. So we just replace that with 02. And the same applies for the other row as well. So DB2 examines the entire rows for repeating patterns and not just one particular field or parts of rows. So if there is some repeating pattern found in continuity spanning multiple columns, then that pattern can also be added to the table level dictionary. And that is what has happened here in this example. Now if you look at both these rows on the data page, the length of this compressed row is shorter as compared to the uncompressed row. So this is a better form of compression, and this is what actually happens in real time. Also from a DBA perspective, compression can be greatly improved if columns that are highly correlated are placed close together to one another. Now this table design has city, state and zip code columns close together, and this is ideal from a compression perspective. Now placing an unrelated column in between city and state or state and zip code, like if you place salary in between them, then that would basically reduce the ability of DB2 to find larger string patterns, and this will significantly affect your compression ratio. Now let's look at another example with more data. So here we have this original employee table that has these 6 columns, and we have more rows over here. So as I said that DB2 can pick up parts of strings that are repeating. It's not necessary that it has to take the full column length of values into these columns. So here in this example, the string boo is repeating for all these 3 rows. So boo has been picked up for the table level compression dictionary. Similarly, you have this value street into the address column that has been also picked up. For San Francisco and San Jose, San has been picked up as one entry, Francisco has been picked up as another entry. Similarly, Joe's has been picked up. And then in continuation, we have C and 9 as a combination that has been picked up for the table level compression dictionary. And when you see the compressed data rows, so all of these repeating values are replaced with their corresponding shorter symbols in the data pages. I could also have done this a bit differently. I see that in this phone number column, we have some repeating values like 415, 555, then we have 408, 555, then we have Lombard repeating, we have Hyde repeating, as well as the initial address value over here. We could have also taken 41 over here, 51 over here, 109 is also repeating. So there can be many permutations and combinations of how you create your table level dictionary. But creation of the table level dictionary is an automatic process. You don't have much control over it. It basically analyzes the data in the table, and based on a compression algorithm, it picks up the repeating patterns and adds that to the table level compression dictionary. And based on that, the data rows are compressed on the data pages. So this is how a classic row compression works with the table level dictionary. Now let's see how we can enable a classic row compression on a table. So while you're creating a new table, you can specify these keywords compress yes static towards the end of the statement, and that would enable compression on the new table. If you already have an existing table without compression and then you decide to enable compression on that table, then you need to do an alter table statement on that table, and you need to specify compress yes static. So this is how you enable classic row compression on tables in DB2. So that's it guys. Let's move on to our next lecture to understand adaptive row compression. Thank you.